All right, welcome back everyone to our Calculus 3 class notes, and we're on now example 74. And using what we just learned about Taylor's formula for f of xy at the origin, we want to go ahead and find the quadratic approximation of f near the origin and the cubic approximation of f near the origin. So to be able to find the quadratic approximation, I need the first partials. I need the first partial with respect to x and the first partial with respect to y. I need the second partials. Second partial of f with respect to x, second partial of f with respect to y, and then I need the one mixed second partial f sub xy. Okay, so now what I need to do is go ahead and evaluate each of these at the point 0, 0. And the only two that survive then is f sub x at 0, 0 is 1, and f sub xy at 0, 0 is 1. So when I write down what the quadratic approximation would be, which is f of 0, 0 plus x times f sub x of 0, 0 plus y times f sub y of 0, 0 plus 1 over 2 factorial times x squared f sub xx at 0, 0 plus 2xy times f sub xy at 0, 0 plus y squared times f sub yy at 0, 0. I get 0 for f of 0, 0. I get x times 1, because f sub x at 0, 0 is 1, plus y times 0, since f sub y of 0, 0 is 0, plus 1 over 2 factorial is 1/2, x squared times 0, because the second partial with respect to x at 0, 0 is 0, plus 2xy times 1, because the mixed partial of f with respect to xy is 1, and y squared times 0. So the second order, the quadratic approximation, right? This is a quadratic, even though I don't see either one of these squared, because this term is a quadratic term. Each of these have a power of 1. It's a quadratic term. So this approximates x times e to the y near the origin. All right, now what's the cubic approximation? So I keep the quadratic and I just add the cubic term, which is this guy. So now I need the third order derivatives. So I need f sub xx, which is, if I look back up here, f sub xx is already 0, so the third order derivative is 0. F sub xxy, again, since f sub xx is 0, f sub xxy is 0. F sub xyy, so that's f sub xy, and then take the derivative with respect to y, and I get e to the y. So now f sub xyy at 0, 0 is 1. And then f sub y, right, is the derivative of f sub y with respect to y, so it's still x e to the y. So that is still 0. Okay? And then I need f sub xy. Did I do that? F sub x area. F sub xxy, I already talked about that. Okay. So then you plug these terms in, and what I have surviving over here is the 3xy squared times 1. So the cubic approximation adds the term 3 over 6, which is 1/2 times xy squared. So this is a cubic approximation to x times e to the y.